Welcome. I want to go through some points on graphing parabolas. Parabolas are quadratic, so x squared and 2x squared are quadratic expressions. First thing, we'll plug in some values. Graphing is always good to start with some table values. So negative 2 squared is 4, negative 1 squared is 1, 0 squared is 0, 1 squared is 1, and 2 squared is 4. This is known as the parent function. So all transformations, they all start with f of x is x squared. So I've gone ahead and I've plotted those points on the graph here. Now what I noticed is that some folks, what they did is they just connected the points with straight lines, like this, this, and this. Okay, that is not accurate. Don't do that. Okay, remember that a straight line is a linear pattern, and what we're trying to do is we're trying to do a quadratic, which is a curve. So when you do this, let's see if I can take these off. You want to try and draw a curve. So I'm going to just expand this a little bit. So, whoops, that's not what I want. Yeah. Okay, so you want a curve as it comes through, and you want it to curve as it comes through like this, and that represents that quadratic. All right. Now, another thing that is important to understand is, what about the stretch on the parabola? Okay, what happens there? Well, let's look at another example here. Let's do it in green. This is 2x squared is my quadratic function. X is my independent. So negative 2 squared is 4 times 2 is 8. Negative 1 squared is 1 times 2 is 2. 0 squared is still 0. And because it's symmetric, we also have the others. And if you look at how these things line up, it's interesting here. We can see that 1 and negative 1 are actually, instead of 1, they're 2. So we've got a value here, and we got a value here. Okay. Also, we notice that 2 and negative 2 are 8. So at this point, 5, 6, 7, 8, we've got a value here, and 5, 6, 7, 8, another value here, and the vertex is the same. Now, when we go ahead and we graph these, we try and draw like a curved type drawing on here. And that one also, you can see it looks kind of straight. We don't want it straight. This is also curved at the bottom here. Now, when we look at this, you can also tell, just looking at the parabola, what the stretch factor is. Okay, so the way we do that is x squared, there's a point at 1, 1. Okay, so that is the parent function. However, the other one extends, let me put these on here. So this was at 1, 1. The other one is at 2, 1. So what we notice is the second parabola, the green one, is at 2, 1. The red, x squared, is equal to 1, 1. So the stretch factor, since it goes from 1 to 2, that means that the stretch equals 2, because every point was twice as high. You can just look at the single point to figure out the stretch factor. So therefore, instead of the parent function of y equals x squared, because there's a stretch factor, it's y equals 2x squared.